Hello, everybody, and welcome to season 5 of the JUXT cast. It's coming live from Milton Keynes, City of the Future, and it's with Malcolm Sparks, Jeremy Taylor, and Alex Davis. Hi, Jeremy. Say hello.
Hey, yeah, I'm Jeremy. I look after XTDB. Hey, Alex.
Hello, I'm Alex, and I don't look after much. I look after the hiring board.
Brilliant. All right. Well, we've introduced ourselves. No, you've got a connection with Milton Keynes, haven't you, Jeremy?
Well, that's where I'm from. This is my hometown. I was born about a mile up the road from where I'm stood. Don't live here currently, but I do have a lot of fondness for the city.
Yeah.
Well,
for those of you who don't know, Milton Keynes is a city that was started about in the 1970s, and it's a very futuristic city. It's all kind of modelled in a very progressive way with underpasses and redways and cycle lanes. It's a very kind of design city, would you say? What was it like growing up here?
Well, I always thought it was strange that the rest of the country wasn't filled with roundabouts and broad sidewalks or streets. So I feel like going to any other town in the UK is a bit more sort of cramped, and I felt like it was at home. So no, this is definitely a place where I feel very sort of free, and you can cycle around, and it's safe and pleasant, and lots of trees. It's one of the leafiest cities in the UK.
Yeah, it's a nice place to live. But I've learned that if I go internationally, people don't know what Milton Keynes is, or some people have heard of it, but not everybody. So I like to say, well, actually, it's where do you come from? I come from Bletchley Park, because people do know where that's from, thankfully, because of some Hollywood movies around Alan Turing, and it is cool, and the Enigma machine and the code breakers and all that story. So it's more cool from a tech point of view, saying you're from Bletchley Park. That's kind of the home of the computer. So that's what I say.
Well, I was at a hotel just last night, and they've got it all themed with Red Bull Racing. So that's another big brand name based here.
Oh, yeah. Red Bull. Okay. So, yeah, how would you imagine you'd get all that money from a sugar drink? But they did.
Kudos.
Yeah. So, Alex, we've just come back from the Post-Conj.
Yeah, and very smooth travel this time around. Not like Strange Loop, where there is no direct flight to St. Louis from London, but there is to Durham in North Carolina. Yeah, so much smoother.
Direct flights from Bletchley Park every day.
Yeah, not quite.
What was your favourite talk?
I mean, might be cliche to say this, but Rich Hickey's talk was good to see Rich Hickey speak, having sort of watched a whole bunch of videos and sort of, sort of this moment of, oh wow, it's this person in real life that I've seen talked about on the internet and watched videos, and seeing him live was pretty cool. I think the talk before him by Sam, what is his last name?
Ritchie.
Sam Ritchie, that's the one. That was also really good. Lots of cool graphics and awesome demo there. Yeah, lots of good talks.
Jeremy, your favorite talks?
So the opening talk was on vector symbolic architectures, which is sort of a lofty AI research area where I can't remember the speaker's name, but she
Karen Meyer.
That's right, Karen. Yeah, she had been experimenting with this vector representation of doing symbolic AI, but using Clojure and then this sort of fast Apache Arrow-based processing system. So yeah, a really interesting talk, and it sort of paints this alternative view. Maybe we'll talk more about ChatGPT later, but this alternative view on the AI ecosystem and the opportunity to do some relevant cutting-edge experimentation from Clojure, which I think is like a fascinating thing to think that we have this very high-performance tool at our fingertips.
Wow. My favorite was, I think, one I went to was Eric Dallow's on Clojure LSP, which is really about how you do Clojure at scale. I mean, Nubank have got something 1,800 engineers, and how you get everybody working in the same Clojure code bases with that number of people. It just shows the sorts of things that you can do with Clojure LSP to help you scale. I thought that was really interesting. I mean, we're not that big yet, but we're, JUXT.
Well, it sounds like they have thousands of microservices, so it's probably basically one person to a service.
Oh. Talking of microservices, we've got recent news that Amazon, doing the, hot on Twitter and Hacker News, the Amazon Prime that used for one of their microservices or one of their functions have begun to move away from microservices and back to monoliths, which has ushered a kind of whole load of people commenting on the whole thing. And I've done a few tweets in this direction around the difference between microservices and monoliths, and people are beginning to question the received wisdom that microservices are all good and monoliths are bad, and sometimes the answers are a little bit more complex.
Was it microservices? I thought it was just serverless. I don't know where the line between microservices and serverless is, but what I read was that they had a bunch of Lambda functions that would be spun up all the time, and they just moved it to a monolith.
Yeah, I think so. I think that. I mean, my comment on that was really about. I think that there is some problem with the tendency to break everything up and put it on the back of a network call. And there was kind of something I was reading about, the thing that monoliths have that other architectures don't is that they have L1 caches and really, really fast. They have very, very low latency access to their data and all that stuff. Whereas microservices, you're talking about JSON encoding, security, access tokens, JWT, just to do a single call.
It is interesting watching people spend quite a lot of time and in trying to move everything to the edge, including like databases, because you move some function to the edge and then you go, oh wow, this function's really fast, but it has to go off to some database which isn't at the edge, and then we have to move that to the edge, and then when everything gets to the edge, then you have to worry about what if two people at different edges want to share information, and then you have all of these other problems. And at some point I kind of feel like just taking the trip once to wherever the central service is and then having all of those little hops be done locally or in the same region might be better than trying to split everything out into the edge to save 100 milliseconds of time.
Well, time is the big thing, and I'm not going to talk about temporal databases in this context, but the latency involved in doing any kind of fetching over a network is going to be the killer in the future. That as computers continue to evolve, get more and more parallelism, it's the latency in the network hops which is going to dominate performance. So wherever you can minimize that, you should. And I think databases have shown us ways of thinking about this in the past. And the original vision for databases was Ted Codd's paper about a relational model for large shared data banks. It's about how do you communicate data without having to introduce loads of joins over networks. You want to just do the join in one place and share access to data.
Yeah, that's an interesting term, shared data bank. That does imply having a bank does imply that it's all in one place, it's all together so that you can join across it. You're not having to navigate and find state in pipes and across links and in different databases.
Well, I think with closure, we very much appreciate you don't want to hide state between objects. Much better to shove lots of state in a map and have one place where you can do transformations on it. So I think it's the same philosophy, just applied over the network.
Yeah, this is my kind of main concern about architecture is that it's information technology, not just technology. It is about information, and where we get our information is in databases. So if you're building any service that needs to get information and you have to go to a service to get it, by the time it arrives at your service, it's already out of date. It could be out of date. It could be stale. And then you're making decisions based on out-of-date data all the time. And this is very different from how, we were talking about consistency. We were in Copenhagen not so long ago, and I was having a conversation with Martin Clausen, and the reason I wanted to speak to him is because he's got a background in IBM mainframes. So I know, Jeremy, you're from IBM originally, and you probably know more about this topic than I do. But I did ask him, is it true that the IBM the mainframe model, as you see it in the black and white photos, is really about a single stream of functions that are being queued up? They're jobs. They were called jobs, and they had job control language. But it's simply, there is a stack of punch cards, and punch cards have to go in order. You can't there's only one place in the mainframe to slot them in, and they have to go into a particular order. And when a punch card program is running in a mainframe, it accesses state which is on these kind of tapes that are, in these films, going round and round and round. But it is the latest, or at least you think it's the latest version of state. And then the next job comes along and says, what is the, the balance of this account? And it goes round, round, round. Oh, it's 42. And then it will add some numbers. So when IBM moved to a multi-processor environment with multiple cores and CPUs, they had to recreate this transactional queue linear system. And the way they did that is through inventing this notion of transactions. That was because that was just reflected the way that computers had operated up until that point. And that was interesting. I'd asked him, is this really where transactions come from? This kind of the idea of just having paper cards and in one order. And I think he said yes, that's exactly what, that's the sort of quality of service, quality of data processing we're trying to approach. And we've lost that because now we're processing on data that's stale. We need, this is, again, kind of talks to the, we're over at Copenhagen giving a talk on atomic architecture, but one of the principles of atomic architecture is that you process data in a consistent way. Data consistency is brought back to the heart of the processing system.
I think the biggest tension that is seen in the modern era is people wanting to do things, Alex used the word, at the edge. People want to have the app be as fast as possible from different regions around the world and avoid these global round trip times. So yeah, back in the 70s, it was fine to have mainframe in different parts of the country servicing different users potentially, or the the latency was acceptable. It didn't matter if it took 5 seconds to book an airline ticket. That was fine. Whereas now, people expect sub-second responses, regardless of where the server is. They don't care. They just want it to be fast. So you can't really have both things at once. You have to give somewhere. You have to sacrifice consistency if you want fast responses.
Yeah, and also often there are more and more apps that are real time, and the people that want to collaborate with each other in real time are in the same region. And if you run your, I don't know, live editing, Notion, Google Sheets, whatever it is, service out of a single data center in the UK, and there's a team in Australia that want to use your tool, then each time that they edit something, they're going to have to be a round trip from Australia to the UK and back for them to see each other's edits. And that is actually going to be pretty significant latency for seeing someone's cursor or text move around. So I think sometimes you do have to sort of lose that simplistic model of having a central source where everything happens in order because of scale or geographic distance, but not always. Like the cases where you do actually need it is not as many as the cases where people seem to be moving to it. Like there are a lot of people moving, their very simple, Twitter type apps or whatever to some horrendously complicated distributed network when they only have 50 users. And yeah, that is the problem, I think.
I was reading some analysis the other day about the growth of different database workloads and who's doing well in the cloud and that sort of thing. The analysis said that single writer systems are growing much faster than multi-writer systems. So even though Spanner and CockroachDB and these other systems have some very clever technology, it's still not fast enough and general enough and cheap enough to really compete with just spinning up another RDS server in a particular region. So that's what the industry seems to be preferring is live with the constraints of having high latency across certain regions, maybe sacrifice some consistency, but the throughput you get and the simplicity in the architecture you get from having a centralized database in one region is preferable.
Yeah, I think you mentioned that magic word simplicity, and I think it is definitely true that consistent systems are easier to reason about because when you process against stale data, then you have all kinds of race conditions, which one got there first, physics comes into play. So to bring back simplicity means bringing back consistency as a default. Now, I completely understand Alex's point of view that sometimes that default doesn't work for your use case and you have to break that default. But I'm saying that should be the default, and then you should have a very, very good reason, and it should be a good business reason or a user reason to trade off consistency. Otherwise, you should keep it.
I guess the problem is what you see is, or you read stories where people start some app, like Twitter is a good example actually, because Twitter was started as a Ruby on Rails thing. It was very much like let's just do this simply and not think about performance or scale, and let's just like get this thing working. And then it exploded in popularity. You had, massive events like the World Cup and whatever, and Twitter was going down all the time. And then they needed to spend like a huge amount of time and effort and money in making it scale, web scale, or, whatever. And now you get people being afraid of that. And when they're launching their business or they're starting their project, they're going, oh, well, we can't just use this because it won't scale. And it's not, going to scale to billions of users, which is where we want to be. And even though none of them actually ever end up getting to that point, they want to be sure that their service and their infrastructure can handle it if it does happen unexpectedly. And I do get that point of view. I just think that you have to have like realistic expectations, and sometimes it is better to go the simple route and then have to scramble about the scale than it is spending a year in development hell not releasing anything because you started off with like this crazy infrastructure.
Yeah, I think that's very true. I mean, you mentioned the World Cup. I mean, with football, people think because the Premiership and the World Cup are the popular football events, that is football. But that's just the top 0.01%. And I think we have the same delusion or selective bias when it comes to systems, because we hear about the problems at Twitter and GitHub, and we say, oh, we can't use Rails, but in fact the huge vast majority of systems that run everyday processes in everyday companies, the vast majority of them have got nowhere near the scalability problems and requirements of these incredibly successful companies. And so there's an enormous selection bias going on, and that we should actually the fashions that drive technical architectures are driven by this selection bias, which is a great shame, because it means that a lot of companies are like woefully underserved trying to build Ferraris when they really want to be building Volvos.
Yeah. Well, I think part of the trouble is that the trend is towards more and more sort of agile iterative development, and so everyone's terrified of actual capacity planning, like trying to estimate usage growth and predict. Like people seem to be less interested in that, spending less time on that, and quite rightly, because it's a bit of a chore. But I think if you can do some back of the envelope calculations and manage those margins for error and routinely check the logs to check you're not sort of at too high CPU percentage, you can provision and scale accordingly, and then figure out at what point do you need to really start thinking about scale. But people are wanting the easy answers too quickly. And
there are always other. We talk about Ruby on Rails. GitHub to this day, I believe, is still running on Ruby on Rails, and so there are other options of scaling technologies that are available to you, which you may not know in advance.
Yeah, they have been going down quite a lot recently, though. So I don't know if I'd mention that one.
Wrong week to make that comment. Anyway, moving on. So, what else has been happening in the news? Well, as wouldn't be right to know without mention the wave of new AI news that has been we've been deluged with every day since early January. I think what's been going on. You've been playing around with AI, haven't you?
Yeah, I think there are some really good use cases for it. I think it's gotten a lot of hype. It's gotten a lot of people talking about, oh, will it replace all our jobs and blah 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 blah. And I think it's like it is a big step forwards technologically. I don't know how comparable it is to something like the production line or like the industrial revolution type thing. It's probably not going to be that big, but it is like a big step forward in technology, and it's an emerging tool that will probably replace some amount of jobs in the future. But as with all technological advances, they are inevitable. You can't say, oh, let's not do them. Let's hide all of our data from the AI, because it's too late for that. But at the moment, it is still quite far off of replacing any anyone's job that requires some level of experience and knowledge. Because every time I talk to ChatGPT, it seems like it knows a lot, and until you actually know quite a lot on the subject, and then you realize that it really doesn't know that much at all, because it doesn't know anything, because it's just like making stuff up. And a lot of the time it makes stuff up that's correct, and a lot of the time it makes stuff up that's wrong. But yeah, I think it has some use cases. I think especially around boilerplate things that are like sort of these email chains which are kind of just the done thing, but don't actually serve any real use, and you just have to type a load of waffle. It's good at waffling. I think it's quite good at changing the tone of something while keeping the original intention. So if you leave comments on someone's PR and you just don't want to spend time thinking about how to make this friendly, it can friendlianize unfriendly comments, which is useful. And I think Copilot is genuinely a useful tool. Messes up the brackets enclosure, so I have switched to par infer. But the fact that I've switched to par infer, which I don't prefer over par edit, just because Copilot works better with it, I think shows how useful I do find the autocomplete.
Well, I think you're the expert around this table, perhaps on actually using it for highly productive activities like coding. I haven't tried Copilot or anything like that, but I did ask it to write some data log and it failed. I also haven't tried the latest Chat GPT version, so maybe I'm out of date. But I do think I agree. It's sort of a very promising thing that will be inevitable to some degree, but I am at least reassured. I think that I'm not expecting like a runaway self-improving AI coming out of this particular vein of research. I think what we're looking at something that's disruptive to industry rather than humanity.
Yeah, it's still very expensive to train these models, right? You need a huge amount of computing power. You can't sort of do it quickly in real time. There are sort of models that run on people's devices, but they're still not very good compared to what ChatGPT. I mean, the like GPT models that OpenAI have are massive, and they require like seriously expensive bits of hardware to produce those things. So eventually that will come down, but I think it's going to be some time. Yeah, I think that there is definitely like good real world use cases for it right now. And I think Copilot and DALL-E and Stable Diffusion and all these things, like they are actually being used. I think there are places where it's used where it shouldn't be used yet, or it's just like it's not making things better, like all of the lazy news articles or blogs that get generated. But then that was happening before anyway, and maybe this will pump out enough of them that people start getting fed up of it and demanding that people spend effort on their news articles, maybe.
Yeah, my take is that I think it is very significant, but it's significant at the surface where people are. We're talking about technical infrastructure. There's a great lyric by the Pretenders, Chrissy Hynde, which is always on my mind. It's some things change and some stay the same. Some things stay the same, and infrastructure changes very, very slowly. Stuff that runs banks and hospitals and stuff, it's just ingrained. And then as you go up the layers of sediment, you get to stuff which we work on, programs and things that change. And then you get operating systems and things that AI is not going to have a huge dramatic effect on things that are buried deep in infrastructure, but it will have an effect on I think the user interfaces to infrastructure. So I think chat is a very important interface. We spend a lot of time, the user interface is very primitive between humans and computers. It's often form-based frustration, trying to thumb your way into paying for a car park or something on a phone, or it's very primitive. And I think AI is going to have a huge impact on the human computer interface just because it does a fantastic job of pretending to be a human. So that's where it will have an impact. But I do think this, I take from this that there is a latent potential with having very good AI in terms of being able to run transactions or call into existing infrastructure through APIs. So I think there will be a great disruption in the way that things are done, how humans deal with society, booking car parks and hospital appointments and booking restaurants. That will be impacted. But I think it's the same things we've been saying for a long time, that in an internet connected world, that we know the web has opened up this potential for companies to do transactions between each other and much more much more significant way than other approaches based on EDI and XML and so on. We know that the API idea is here to stay, and it will drive more and more of the economy. But where I think it's really important is that to date, most APIs have been very private. You'd have mobile apps talking to the, owned by a company. And if you do something, Airbnb will have an app, and their Airbnb will talk to the private Airbnb API. But more and more companies, and I'm not talking about just the top 0.1% Premier football teams. It will be, everyday companies will have to produce secure APIs that are public and that can be exposed to the world of the bots. Otherwise, they will miss out on all the innovation that's coming downstream. So I do predict a renaissance in kind of API development and API and companies really considering the API to be as important as their existing user interfaces.
Yeah, I think there's no way that this whole AI topic would have got anywhere near as much attention if OpenAI hadn't released an API. If they'd have just released ChatGPT and locked it behind this sort of interface and you can talk to something, it would have got a lot of attention. It's still a very impressive tool, but the API has really allowed a bunch of other companies very quickly to integrate with it. So Notion has a GPT powered thing where it can write some documents for you. There's a similar thing with Grammarly where it can, change the tone or add bits to what you're writing. There's obviously all of the Copilot stuff. GitHub has actually released a CLI tool now that you can just type question mark, cut the last 20 seconds out of this video and it will write the FFmpeg thing in the shell for you. And there's a whole bunch of other things that people have just come up with to integrate with it using the API. And I think that it's always been surprising to me how many people really spend all this time on a product. I think Notion's another good example because when they came out, they didn't have an API, and they had this tool where you put your documents in, and it's not just documents; they have databases, and you can put stuff in with tables, but you're locked into using their front end, which isn't always what you want. Sometimes you want to automate it, and so people had to reverse engineer their API, and there's all these GitHub projects for Python and Go and JavaScript where someone's figured out Notion's private API and sort of reverse engineered it. And these things got thousands and thousands of stars on GitHub and used all over the place. And then eventually Notion started releasing.
So almost reverse engineering Notion's.
Yeah, exactly. And it's, you don't want to rely on a private API, right? Because Notion can change it whenever they want, they can break it. And that, I guess, is why they didn't do it in the first place, because having a public API is a lot of work to maintain and document and all of that sort of thing. But I still think that it is an important thing to have in this day and age, and I think that it's something that the people who make tools and open source software that makes putting together an API, documenting it, having all of this process around it as easy as possible is going to be really important.
Yeah, I agree. I mean, it's one thing to have a conversation with a ChatGPT, explaining your kind of symptoms to it, and for it to guess what maybe you're having a heart attack, but the ability for it to say, I think you're having a heart attack, would you like me to, I've booked you an ambulance and an ambulance is on its way. That's when it gets real. That's when it becomes a really useful tool. So I think at the moment we're just seeing the beginnings of it. We're playing around with the interface, but it's when the rubber hits the road, when the AI can talk to meat space and the infrastructure. And this is, of course, the big dystopian fear that we'll attach an AI to an artificial general intelligence to infrastructure. But it must happen, and it will happen. And I don't want to get into the ethics and the safety of it. Only to say that it will be all Microsoft's fault. Okay, moving on. Toy of the week, our much forgotten section that we had in one podcast, I think in season 1. This week's toy of the week.
Well, okay, yeah, we have got a toy of the week, but I just like to point out. Yeah, I know. I'm just pointing out that toy of the week was part of a running joke where we had something of the week and we would only do it once, and now you've ruined it by having a second toy of the week.
Oh, season 5, we can change the rules.
Okay.
I'm sure we've got new toys that coming. I mean, we've got an owl.
We've got an owl. Yeah. It's this camera that's split.
Well, it's
split
the one
the
thing
video.
that you can't see on the video.
Yeah.
By definition.
Yeah. You need a mirror. But actually, Jeremy's disappeared from it. It's because you're not speaking. I guess you have to.
Okay, testing.
Oh, there we go. So yeah, so when someone speaks, I guess it has some directional microphone and it has a 360 camera and it will put people in. It's really just because we have this big table in our meeting room, and we had like a few webcams that we tried, wide angle ones on top of the TV, and they're either really low quality but fit everyone in, or they're like way too zoomed in, or we tried that one that sort of has a little motor and it moves around, but then it's just annoying and it's distracting for everyone. So this 361 in the middle that has a speaker in it and follows everyone is a pretty good toy. I mean, I think it's quite expensive as far as webcams go, but once you get into all the Zoom room stuff, you can spend basically.
We recommend it. We're happy with it.
I think we're happy with it. Yeah, we need to sort out the echo in this room, and then we don't have to have these microphones. But yeah, I think we're happy with it.
I mean, this table is the famous table from season 1, and we had it in our old office. And I will maybe post up to a kind of a YouTube channel all the photos of the
moving the table
and the videos, because that was some project, and it only just fit into this new office by we were just millimeters inside the tolerance of it all. But
what definition of the word famous were you going for there?
The famous table. Well, I mean, yeah. Okay. Well, moving on to the next topic. I think engineering wardrobe. I think there's the next section. This is what the hell are you wearing, Alex? And
right. We're going to talk about developers' clothing choices, aren't we?
Yeah, new section.
Well, I exclusively wear clothing provided to me for free at conferences now.
So what are you wearing today?
This is my Strange Loop t-shirt that I got at the Strange Loop conference.
Very good.
Which I'd recommend. It was a fun conference.
Jeremy isn't wearing any branded gear.
No, I try and stay neutral so that I'm corporate friendly. And this is actually the first time I'm wearing this top, so just
very good.
Trying to emphasize.
Nice. Yeah, I'm wearing the official Safari top. When you do a Safari, so a Safari, I think we've got a few of the YouTube channels. You see some Safaris. So these are internal tech events that we do where we talk about some tech topic. And if you do it 1 or 2,
I think you have to do 3 Safaris to get the hoodie,
and then you get a hoodie, and that's why we have the Lambda with the flash,
with the tiger stroke. Yeah, no, I think it's a great piece of JUXT merchandise. We should make the JUXT shop. People can buy our clothing, and then we can always pivot once AI takes over from doing the software for us.
Very good. Okay, coming up, JUXT is 10 years old, or is 10 years old already. We're having a party in 2 weeks' time, which is probably about the time that this podcast will go out. So we're looking forward to the party, Alex.
Yeah, I mean, I guess it's party came about partly because it's 10 years, but also because we put a lot of work into a conference that was going to be held in mid-2020. Obviously, certain viruses had something to say about that, and it was cancelled. And so we thought we could reuse some of that work, some of the songs and skits that we put together. And we're going to put that on in the same venue that we had planned, which is Wilton's Music Hall in London. I'm pretty excited about that. So yeah.
And it is invite only, but if you're listening to this, and if we put it out just before and you really want a golden ticket, then get in touch.
Yeah, I mean, we'll film it as well, right? And we'll probably have some YouTube videos out of it, and some talks that we're going to do. So during the day,
as always, a tech conference, internal tech conference at the event, and a party, skits, dances, songs.
But the talks really are like, they're not even for the audience. We're doing them mainly to film them and then put them on the internet so everyone can see them. So yeah, check our YouTube channel if you haven't already, and maybe some of those will be on there already. And
it's the live performance of Alex's song, which is already on YouTube.
I wrote a song about text editors that were made before I was born. So
Holy war. All right. I mean, anything to wrap up with, Jeremy? Closing thoughts?
Well, I mean, the party's going to be awesome. Yeah, I've got a talk in progress for that. The working title is Update Considered Harmful. But then I was on Hacker News yesterday and I saw people saying the expression considered harmful is harmful itself. So maybe I'll have to rethink that. We'll see.
No, I like tropes and memes and idioms. I think it's a good talk. Anyway, thank you everybody for listening. That was a kind of a trial episode that we've done. Hopefully we'll do some more every Friday. But anyway, we'll close off. I'm Malcolm Sparks.
Alex Davis.
Jeremy Taylor.
Listening. Goodbye.